Hi guys! Welcome sa Engineered Math Channel. Sa video na to ay tuturo ko sa inyo ang theorems on limits of functions. So kung gusto niyo itong matutunan, just keep on watching. Okay, so meron akong naunang video about limits of functions. So sa video na yon ay diniscuss ko kung paano i-represent at kung paano basahin ang notations for functions, as well as dinefine ko kung ano ba ang limits at kung paano ito i-analyze at hanapin ang value nito given the graph of a function. So ngayon ay tuturo ko naman sa inyo ang iba't ibang theorems on limits of functions para mahanap natin yung exact value ng limit without considering the graph. So magbabase tayo dito sa mismong equation ng function. Okay? So limit theorem 1. If m and b are any constants, then limit of mx plus b as x approaches a is equal to ma plus b. Okay, so kung meron ka raw function na linear, which is f of x is equal to mx plus b, slope-intercept form, then masosolve mo yung limit nito as x approaches a value, let's say a, with the value equal ma plus b. So parang isa-substitute mo yung a doon sa x nung mx plus b. Okay? So halimbawa, limit of 3x plus 5 as x approaches 2. So yung function natin dito ay 3x plus 5. So, ang limit daw netong 3x plus 5 as x approaches 2 ay substitute lang natin sa x yung value na 2. So, we have 3 times 2 plus 5 is equal to 6 plus 5 or 11. Okay, so direct substitution lang kapag ang function natin ay mx plus b. Okay? Next, limit theorem 2. If c is a constant, then for any number a, limit of c as x approaches a is equal to c. Okay, so this time yung f of x naman natin ay constant function. So therefore, kahit anong value natin ng x dito, iisa lang yung magiging value natin ng function, which is c. So ang graph dito, di ba, ay horizontal line base sa video ko about graph of functions. So ngayon, ano daw yung value ng limit of c as x approaches a? Obviously, c pa rin. So kahit anong number ang approach na value ng x, automatic, dahil constant yung given function natin, yun pa rin yung i-approach ng function natin. Okay? Example, limit of 7 as x approaches 5 is, so wala tayong pakialam sa in-approach ng x as long as constant yung value ng function natin, which is 7, sa 7 pa rin siya mag-approach. Okay? Next, limit theorem 3. Limit of x as x approaches a is equal to a. Okay, so this time, ang f of x natin ay x, which is identity function, according dun sa video ko about graphs of function. So, it is also a linear function with a special case na m x plus b, where m is 1 and b is equal to 0. So, kapag ganun, ang magiging limit mo raw dito kapag yung x mo approaches a ay kung ano yung ina-approach din nung x na value, which is a. So, parang isa-substitute mo lang din yung a dito sa x. So, parang a nga siya. O kahit anong value man yung i-approach ng x, magiging equal yung limit ng f of x na x sa value na yun. Okay, so for example, limit of x as x approaches negative 6 is, so therefore, the answer is negative 6 according to limit theorem 3. Okay? Next, we have limit theorem 4. If limit of f of x as x approaches a is equal to L, and limit of g of x as x approaches a is equal to m, then the limit of f of x plus minus g of x as x approaches a is equal to L plus minus m. Okay, so parang addition and subtraction lang to of two functions. So kapag in-add or minus mo raw yung dalawang functions na may certain limit L tsaka m as x approaches both a, so dapat parehong a, then yung limit nun ay yung sum or difference lang din nung actual limit nila na L tsaka m. Okay? So, for example, if f of x is 2x plus 5 and g of x is equal to x, then, pag hinanap natin yung limit ng f of x as x approaches 1, so, applying theorem number 1, which is yung mx plus b form, substitute natin tong 1 sa x. So, parang 2 times 1 is 2 plus 5 is 7. Okay? Then, dito naman sa g of x, identity function. So, limit of g of x as x approaches 1 is So, kung ano yung ina-approach ng x, yun din yung magiging value ng limit natin according sa theorem number 3. So, therefore, limit of g of x as x approaches 1 is 1. Okay? So, since pareho yung ina-approach na value ng x nila na 1, pwede natin silang pag-addin as one limit, and then yung magiging sagot natin ay yung sum ng limit nila individually na 7 tsaka 1. So, therefore, yung limit of f of x plus minus g of x as x approaches 1 is, so kung plus muna, i-add natin yung 7 plus 1 is 8. So, kapag minus naman, isusubtract natin yung 7 minus 1 is 6. Okay, so ito yung plus, ito yung minus. Okay? So, another concept na pwedeng yung ma-imagine dito ay pwedeng yung i-distribute yung limit sa functions. So, kung meron kang f of x plus minus g of x, pwede mo silang paghiwalayin by distributing limit of f of x first plus minus limit of g of x as x approaches 1. Okay? Next, we have limit theorem 5. If limit of f sub 1 of x is equal to L sub 1 as x approaches a, and limit of f sub 2 of x as x approaches a is equal to L sub 2, until limit of f sub n of x as x approaches a equals L sub n, then limit of f sub 1 of x plus minus f sub 2 of x plus minus plus minus f sub n of x as x approaches a is equal to L sub 1 plus minus L sub 2 plus minus plus minus L sub n. So, ito ay generalization lang ng limit theorem 4. So, kung meron kang more than 2 functions na given, let's say, f sub 1, f sub 2, f sub 3, and so on hanggang f sub n, tapos may certain limit sila na L sub 1, L sub 2, L sub 3, hanggang L sub n, pwede nyo i-distribute yung limit na yon kapag in-add or minus nyo yung lahat ng functions na yon as x approaches a. So, therefore, parang dun sa example natin sa limit theorem 4, i-distribute nyo yung limit, tapos kung ano yung limit ng bawat function na yun, let's say L1, L2, L3, L sub n na nga, i-add nyo lang din yung limits nila. Yun yung magiging sagot doon sa limit nun sa difference or sum nung mga functions na yun as x approaches a. Next, we have limit theorem 6. If limit of f of x as x approaches a is equal to L, and limit of g of x as x approaches a is equal to m, then limit of f of x times g of x as x approaches a is equal to L times n. So, this time, it is the multiplication version of limit. So, kapag meron ka raw limit of f of x as x approaches a na nag-a-approach sa L, at limit of g of x as x approaches a nag-a-approach sa m, then pwede nyo ipag-multiply yung limit ng dalawang function na yon as x approaches a din dapat, then yung magiging sagot ng limit ay yung product ng individual limit nila. So, for example, f of x is equal to x and g of x is equal to 2x plus 1. So, kung hanapin natin yung limit ng f of x as x approaches 3, so, obviously, identity function lang siya. So, kung ano yung ina-approach natin ng x na 3, yun din yung value ng limit natin. So, therefore, it is equal to 3. Okay, next, kapag g of x naman, so, limit of g of x as x approaches 3, so, mx plus b or linear function. So, substitute nyo lang yung 3 dito sa x, so, solve nyo yung limit ng g of x na 2 times 3 plus 1 is 6 plus 1 or 7. So, therefore, kapag hinanap natin yung limit ng f of x times g of x as x approaches 3, i-multiply nyo lang yung dalawang individual limits nila na 3 tsaka 7. So, we have 3 times 7 or 21. So, parang pwede nyo i-separate yung limit doon sa dalawang function and then i-multiply nyo sila sa isa't isa. Okay? Next, we have limit theorem 7. So, if limit of f sub 1 of x as x approaches a is equal to L sub 1, limit of f sub 2 of x as x approaches a is equal to L sub 2, until limit of f sub n of x as x approaches a is equal to L sub n, then the limit of f sub 1 of x times f sub 2 of x times times f sub n of x as x approaches a is equal to L sub 1 times L sub 2 times until times L sub n. So, parang generalization lang din to ng limit theorem 6. So, kung meron kang more than 2 functions, let's say f sub 1, f sub 2, f sub 3, and so on until f sub n, kapag kinuha yung limit ng mga functions na yon, yung product ng limit ng mga functions na yon as x approaches a, na merong certain limit as x approaches a, let's say L sub 1, L sub 2, hanggang L sub n, kapag minultiply nyo yung mga functions na yon, tapos hinanap nyo yung limit as x approaches a then yung magiging sagot dun sa limit nila ay yung product din ng individual limits nila na L sub 1 times L sub 2 times times L sub n. Okay? Next, we have limit theorem 8. If limit of f of x as x approaches a is equal to L and n is any positive integer, then limit of f of x quantity raised to n as x approaches a is equal to L raised to n. Okay, so kung meron ka raw function na f of x at yung limit niya as x approaches a ay L, then kapag ni-raise mo yung function na yon sa n at hinanap mo ulit yung limit as x approaches a, then yung sagot ay yung limit mo na L, i-raise mo rin dun sa power na n. Okay, so for example, limit of 5x plus 7 as x approaches negative 2. So itong function natin ay 5x plus 7. So using limit theorem 1, masasolve natin yung limit nito as x approaches negative 2 ay substitute nyo yung negative 2 dun sa x. So we have 5 times negative 2 is negative 10 plus 7 is negative 3. So therefore yung limit natin dito ay 3. Negative 3. So therefore yung limit natin dito ay negative 3. Parang yun yung L natin. So therefore, kung ni-raise natin sa power of 4, yung original f of x natin na 5x plus 7 at hinanap natin yung limit nun as x approaches negative 2, kung ano yung nakuha nating limit na negative 3, i-raise nyo lang din sa 4. So, therefore, the limit is negative 3 quantity raised to the 4th power, which is equal to 81. Okay? Next, we have limit theorem 9. So, if limit of f of x as x approaches a is equal to L, and limit of g of x as x approaches a is equal to m, then the limit of f of x over g of x as x approaches a is equal to L over m, if m is not equal to 0. Okay, so this time, division naman. So, kung meron kang limit ng f of x as x approaches a is L, and limit of g of x as x approaches a is m, pag dinivide mo yung f of x over g of x at hinanap mo yung limit as x approaches a then yung magiging sagot ng limit natin ay division. Ay yung quotient lang din nung dalawang limits nila individually, which is yung L over m. Dapat yung m mo not equal to 0 para define yung value ng limit mo. For example, limit of x as x approaches negative 4 is identity function. So, ang limit nito ay negative 4 then limit ng negative 7x plus 1 as x approaches negative 4 is, so mx plus b then. So, substitute mo yung negative 4 dito. So, negative 7 times negative 4 plus 1 is 28 plus 1 or 29. So, therefore, pag dinivide mo yung negative 4, so pag dinivide mo yung x tapos negative 7x plus 1 na function, tapos hinanap mo yung limit as x approaches negative 4, dapat yung sagot ay yung quotient lang din nung dalawang limits nila individually, which is yung negative 4 over 29. Okay? Next, we have limit theorem 10. If n is a positive integer and limit of f of x as x approaches a is equal to L, then limit of nth root of f of x as x approaches a is equal to nth root of L, with the restriction that if n is even, L must be greater than 0. Okay, so this time, kung meron ka uling limit of f of x as x approaches a na equal sa L, then kapag hinanap mo yung nth root ng f of x, tapos hinanap mo yung limit nun as x approaches a, then yung magiging sagot mo sa limit ay yung L pa rin na naka nth root lang din. Okay? Or nth root nung L din. With the restriction na kung n mo raw ay even, dapat L is greater than 0. Which is yung restriction natin kapag meron tayong radical, diba? Dapat, kung ang index mo ay even, dapat yung radicand o yung number or expression sa loob ng radical symbol ay greater than 0. Okay? So, therefore, kung meron tayong limit na cube root of x over negative 7x plus 1 as x approaches negative 4, therefore, diba nakuha na natin tong limit natin to dun sa division, yung negative 4 over 29? Kapag hinanap natin yung limit nito, yung kinilubroot natin itong original function natin dito sa example natin sa limit theorem 9 na x over negative 7x plus 1. Therefore, yung magiging sagot natin dito sa limit ay i-cube root lang din natin yung nakuha nating sagot dun sa limit na negative 4 over 29. Okay? So, ito yung answer natin. Okay? So, para ma-illustrate natin yung different theorems and limits ay mag-solve tayo ng examples. So, 1, we have, find the limit of x squared plus 7x minus 5 as x approaches 3. Okay, so, pwede natin i-apply dito yung limit theorem 4, which is yung generalization ng limit theorem 3, which is yung limit of sum and difference of functions. So, pwede natin i-distribute itong limit sa bawat term. So, parang limit of x squared as x approaches 3 plus limit of 7x as x approaches 3 minus limit of negative 5 as x approaches 3. Or pwedeng minus limit of 5 as x approaches 3. So, kinonsider ko na agad na minus yung operation. Okay. So, ngayon, apply natin term by term yung different theorems na napag-aralan natin. So, dito, pwede itong limit of a power, right? Applying limit theorem. So, parang limit of x as x approaches 3 is equal to etong x natin kasi. So, itong una, pwede natin i-apply yung limit theorem 8, which is yung limit of a power na naka-raise sa 2. So, hanapan muna natin yung limit nung function natin na x, which is identity function. So, therefore, kung ano yung limit nung function natin na x as x approaches, so, therefore, kung ano yung limit natin ng x as x approaches 3, i-square lang natin, which is identity function nga. So, dapat 3 lang yung... So, dapat yung sagot natin dito ay kung ano yung in-approach din ng x, which is 3. So, therefore, 3. Kaso may square siya, so i-square pa natin. Okay? Plus, this time limit of 7x as x approaches 3. So, substitute nyo lang dito yung 3 sa x. So, masasolve natin na 7 times 3 is 21. Okay? Plus, then ito ay constant. So, applying limit theorem 2. So, kung ano man yung constant value mo, yun din yung magiging limit ng function mo as x approaches any number, which is 3. So, therefore, negative 5 din to. So, we have 3 squared is 9 plus 21 minus 5. So, the answer is 25. Okay, by applying all the theorem limits. Next, we have limit of square root of x cubed plus 2x plus 3 over x squared plus 5 as x approaches 2. Okay, so apply natin yung different theorem of limits. So, applying limit theorem number 10. So, pwede natin ipasok itong limit sa loob. So, parang square root of limit of x cubed plus 2x plus 3 over x squared plus 5 as x approaches 2. And then, applying limit theorem 9, which is yung division, pwede natin i-distribute yung limit natin doon sa numerator and denominator. So, parang equal to sa square root of limit of x cubed plus 2x plus 3 as x approaches 2 over limit of x squared plus 5 as x approaches 2. And then, apply uli natin yung limit theorem for the generalization of sum or difference of limits of two functions. So, we have distribute natin itong bawat limit sa taas saka sa baba. So, square root of limit of x cubed as x approaches 2 plus limit of 2x as x approaches 2 plus limit of 3 as x approaches 2 over limit of x squared as x approaches 2 plus limit of 5 as x approaches 2. Okay, so evaluate natin yung limit term by term, numerator and denominator. So, limit of x cubed as x approaches 2. So, power uli. So, applying limit theorem 8. So, hanapan lang muna natin yung limit netong x, which is identity function. So, obviously, 2 lang din kung ano yung approach ng x natin. So, we have 2. And then, i-cube pa natin kasi naka-cube pa siya. So, 2 cube, okay, plus, itong 2x, substitute mo lang itong 2 sa x. So, parang 2 times 2 is 4. So, therefore, the limit is 4. Plus, itong 3, constant. So, ang limit niyan lagi ay, kung anong value ng constant, which is 3. So, dito naman tayo sa denominator. So, we have limit of x squared as x approaches 2. So, applying limit theorem 8. So, limit with the power. So, evaluate muna natin yung limit ng identity function natin na x, which is dapat equal lang din kung saan na-approach nung value yung x natin, which is 2. So, therefore, 2, and then square lang din natin with applying limit theorem 8. Plus, limit of 5 as x approaches 2. So, since constant lang yung function natin na 5, automatic ang limit niya ay 5 din. Okay? So, therefore, simplify na lang natin tong expression. Square root of 2 cubed is 8, plus 4, plus 3, over 2 squared is 4, plus 5. So, we have square root of 8 plus 4 plus 3 is 15, over 4 plus 5 is 9. Or simply, square root of 15 over square root of 9 is 3. So, therefore, the answer is square root of 15 over 3. Okay? Next, we have find the limit of f of x as x approaches 4 given that f of x is equal to x minus 3 if x is not equal to 4 and equals to 5 if x is equal to 4. Okay, so this time, ang given function natin na f of x ay piecewise function. So, diba kung maalala nyo sa video ko about graphs of function, ay nag-illustrate ako doon ng piecewise function. So, nasa-separate yung function natin na f of x into two functions na x minus 1 with provisions na dapat yung x mo ay not equal to 4. So, yung f of x daw natin ay equal sa x minus 3 if your x is not equal to 4 at equal sa 5 kung x ay equal sa 4. So, ito yung graph niya. So, kung i-graph natin yung f of x natin, ito yung magiging itsura niya. So, meron siyang line na x minus 3 with a deletion of this point. Yung point 4, 1. So, ibig sabihin, hindi kasama tong point na to sa line na to. Tapos, meron tayong isang point na 5, 4. Okay? So, ngayon, ang pinapahanap ay limit of f of x as x approaches 4. So, check natin kung ano yung sub-function dito, yung gagamitin natin kapag in-evaluate natin tong limit. Ito bang x minus 3 or 5? So, obviously, dapat dito tayo sa x is not equal to 4. Kasi, di ba, base doon sa equation ko about limits of function, yung dinefine ko kung ano yung limit at kung paano i-analyze yon, hindi natin dapat sineset yung value nung x doon sa actual value na given na ina-approach niya. So, in this example, 4, di ba? So, dapat hindi maging equal yung x sa 4. So, therefore, ang titignan nating function or sub-functions nung piecewise function f of x natin ay itong x is not equal to 4. Kasi hindi dapat talaga maging equal yung x natin doon sa 4 kapag nag-evaluate tayo ng function. So, ito yung gagamitin natin. So, parang limit of f of x as x approaches 4. Okay? So, gagamitin natin f of x dito ay x minus 3, right? So, therefore, we have mx plus b form lang, diba? So, m mo ay 1, tapos b mo ay negative 3. So, substitute mo lang yung 4 sa mx plus b, which is 4 minus 3, or simply, 4 minus 3 is 1. So, therefore, the limit of f of x as x approaches 4 is 1. Note na yung value natin ng f of 4 ay equal siya sa 5. So, hindi sila equal nung limit ng f of x as x approaches 4 at x is equal to 4. So, in geometric interpretation, mayroong break doon sa graph ng line ng f of x natin na x minus 3. Dinilit niya yung point na 4, 1 at meron tayong additional point na 5, 4. Okay? Next, we have given f of x equals x squared minus 25 over x minus 5. A. Use a calculator to tabulate values of f of x when x is 4, 4.5, 4.9, 4.99, 4.999, and when x is 6, 5.5, 5.1, 5.01, 5.001, and what does f of x appear to be approaching? B. Use limit theorem to evaluate limit of f of x as x approaches 5. Okay, so dito muna tayo sa A. So, tinabulate ko na agad yung values nung f of x natin with certain value na given. So, gumamit na lang ako ng calculator. So, mapapansin nyo, dito muna sa una, yung 4, 4.5, 4.9, 4.999, 4.9999, ina-approach natin yung value nung x sa 5, which is coming from the left, or yung left-hand side natin, according dun sa video ko about limit of functions. So, therefore, kapag tinabulate natin to, makikita natin sa table na ina-approach nung value nung f of x natin yung, let's say, dito sa 4, 9, 4.5, 9.5, 4.9, 9.9, 4.999, 9.999, and 4.999 is 9.999. So, palapit tayo sa value na 10. Kapag ina-approach nung x natin ay palapit din sa 5 to the left. Okay? Tapos ito naman sa isang given set of values, 6, 5.5, 5.1, 5.01, 5.001, this time, right-hand side limit naman, which is approaching natin yung x sa 5 from the right. So, ibig sabihin, ito yung magiging value natin ay, so therefore, dapat mataas sa 5 yung mga value natin. So, we have 6, 5.5, 5.1, 5.01, 5.001, and then kapag gumamit tayo ng calculator, masasolve natin yung value ng f of x evaluated at this x's. We have 11, 10.5, 10.1, 10.01, 10.001. So obviously, habang ina-approach nung x natin yung 5 to the right, ay ang ina-approach naman ng f of x natin ay 10 din. Okay? So therefore, pareho yung ina-approach ng value ng f of x natin as x approaches 5 from left at from right. So therefore, yung limit netong f of x natin ay nag-exist as x approaches 5, which is ito ngang 10. Okay, so dito pinakita natin yung concept na kapag nag-substitute tayo ng value doon sa x na nag-approach sa 5, which is not exactly equal to 5, ay ma-approach nga yung certain value din ng f of x na 10. Okay? Now, di naman, kung gagamitin daw natin yung limit theorem to evaluate limit of f of x as x approaches 5. So, sulat ko muna ulit to. Limit of x squared minus 25 over x minus 5 as x approaches 5. So, kung i-apply na natin yung limit theorem, so, limit of x squared minus 25 as x approaches 5 over limit of x minus 5 as x approaches 5, which is yung limit theorem na in division. So, parang limit of x squared minus limit of 25 as x approaches 5 as x approaches 5 over limit of x minus limit of 5 as x approaches 5 as x approaches 5. So, we have limit of x squared as x approaches 5 is 5 squared minus limit of 25 as x approaches 5 is 25 over limit of x as x approaches 5 is 5 then minus limit of 5 as x approaches 5 is 5. So we have 5 squared or 25 minus 25 over 5 minus 5. So we have 0 over 0. So indeterminate. So therefore, hindi natin pwedeng i-apply yung limit theorem agad kapag in-evaluate natin tong function, itong limit ng function sa 5. So meron pa tayong isang step na gagawin. So, diba given tayo na x squared minus 25 over x minus 5. Limit nun as x approaches 5. So, bago natin i-apply yung limit theorem, simplify muna natin tong x squared minus 25 over x minus 5. Divide natin. So, factor natin tong x squared minus 25. So, difference of 2 squares. So, x minus 5 times x plus 5 lang yan. Over x minus 5. So, pwede natin makancel tong x minus 5, right? So, matitira x plus 5. So, therefore, pwede pala nating i-represent tong limit of x squared minus 25 over x minus 5 as simply x plus 5 as x approaches 5. Kasi na-cancel sa denominator yung x minus 5. So, pwede nating i-apply yung limit theorem. So, distribute na lang natin tong limit. Limit of x as x approaches 5 plus limit of 5 as x approaches 5. So, we have limit of x as x approaches 5 is simply identity function. So, 5 lang din. Plus limit of 5 as x approaches 5. So, constant function. So, 5 lang din. So, we have 5 plus 5 is 10. So, therefore, tama dun sa nakuha nating sagot doon sa part A. 10 din yung limit nung part B. Okay? Applying limit theorem. Next, we have given g of x is equal to square root of x minus 2 over x minus 4. A. Use a calculator to tabulate values of g of x when x is 3, 3.5, 3.9, 3.99, 3.999, and when x is 5, 4.5, 4.1, 4.01, 4.001, what does g of x appear to be approaching? And B. Use limit theorem to evaluate limit of g of x as x approaches 4. Okay, so, part A muna tayo. So, tulad dun sa example 5 ko, tinabulate ko lang ulit yung mga values sa isang table. So, dun sa first part, yung mga value ng x ay 3, 3.5, 3.9, 3.999, 3.9999. So, parang x natin dito ay nag-a-approach ng 3 from the left. So, negative. Tapos, kapag dito naman sa kabila, x approaches 3 from the right naman. So, right-hand side limit. So, ang mga value naman natin sa table ng x ay 5, 4.5, 4.01, 4.01, sorry, 4.1, 4.01, tapos 4.001. Okay, so mapapansin nyo, ina-approach na value ng g of x natin dito sa left-hand side limit or from the left ay 0.2679, 0.2583, 0.2516, 0.2502, 0.2500. So, which is nag-approach sa 0.25 or 1/4. Tapos dito naman sa right-hand side limit or yung pag in-approach ng x natin yung 3 from the right, 0.2361, 0.2426, 0.2485, 0.2498, 0.2500 naman yung value ng g of x natin kapag sinubstitute natin itong mga x na to. So, nag-approach din siya sa 0.25 or 1/4. So, since yung limit or ina-approach nung g of x natin yung value na 1/4 both from the right hand at from the left hand side limit, therefore, yung pinaka ina-approach nung g of x natin as x approaches 3 mismo itself, considering right hand side tsaka left hand side both ay 1/4. Okay? So, na-prove natin na by tabulating of value ng g of x as x approaches 4, right or from left, ang magiging limit niya ay 1/4. Okay? Next, use limit theorem to evaluate limit of g of x as x approaches 4. So, this time solve naman na natin. So, limit of yung g of x natin ay square root of x minus 2 over x minus 4 as x approaches 4. So, mapapansin nyo, ito agad sa denominator kapag in-apply natin yung limit theorem 1, di ba sa-substitute natin yung 4 dito? So, 4 minus 4 is 0 agad. So, hindi natin pwedeng i-apply agad yung limit theorem. But instead, may gagawin pa tayong isang step. So, di ba itong square root of x minus 2 over x minus 4, pwede natin itong i-multiply sa isang factor, both numerator and denominator. I-rationalize natin itong numerator. So, square root of x plus 2. So, i-multiply natin sa conjugate nung numerator. So, kung naalala nyo yung tinuro ko doon sa video ko about rationalization of radicals. So, dito rin sa denominator, mag-divide tayo ng x plus 2 para equivalently, 1 lang yung minultiply natin kasi cancel lang sila, diba? So, simplify natin. We have numerator times numerator. So, we have parang difference of 2 squares, right? Kasi conjugate sila. So, same first and second term, tapos opposite sign plus saka minus. So, parang square root of x, quantity squared, minus 2 squared. Right? Over quantity x minus 4 times quantity square root of x plus 2. Okay? Now, simplify natin yung numerator. We have square root of x, quantity squared is parang makakancel yung index natin na 2. So, mawawala yung radical. Magiging x na lang siya. Minus 2 squared is 4 over quantity x minus 4 times quantity square root of x plus 2. So, makakancel yung x minus 4 sa numerator tsaka denominator. Matitira ay 1 over square root of x plus 2. So, therefore, ito na yung hahanapan natin ng limit. So, limit of 1 over square root of x plus 2 as x approaches 4. So, ito yung simplified form nung original expression natin for g of x na square root of x minus 2 over x minus 4. So, ginawa natin yon para ma-evaluate natin yung limit natin as x approaches 4. Which is hindi na magiging undefined, right? So, apply natin yung limit theorem. So, limit theorem. So, distribute natin tong limit as a quotient. So, limit of 1 as x approaches 4 over limit of square root of x plus 2 as x approaches 4. Then, simplify pa natin further. We have limit of 1 as x approaches 4 over, distribute natin tong limit. So, limit of square root of x as x approaches 4 plus limit of 2 as x approaches 4. Okay, so we have limit of 1. So, we have limit of 1 as x approaches 4 is constant lang. So, 1 lang din yung limit niyan. Over, ito, pwede natin apply yung limit theorem number 10. So, pwede nating ipasok sa square root yung limit nung x as x approaches 4 plus itong limit of 2 as x approaches 4 ay constant lang din. So, equal lang yung limit niyan sa constant na 2. So, we have 1 over square root of limit of x as x approaches 4. So, identity function lang yung function natin. So, we have equal din sa 4 yung limit niya. Plus 2. We have 1 over square root of 4 is 2 plus 2. So, therefore, our final answer is 1 over 2 plus 2 or 4. So, simply 1/4. So, therefore, pareho yung nakuha nating value ng limit ng g of x as x approaches 4 using limit theorem doon sa part A, which is yung tabulation of values. Okay? Now, 1/4 din yung nakuha natin. Okay? So, I think that's it for this topic, theorems on limit. So, mahalaga na alam nyo tong basic theorems on limits kasi i-apply natin to kapag nag-aral tayo ng iba pang topic on limits. So mahalaga na naintindihan nyo tong concept ng limit as well as on how to find the limit of a function using these limit theorems. Okay? So sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.